So as we continue working with parallel lines, perpendicular lines, we are going to construct parallel and perpendicular lines. We'll identify parallel, perpendicular, and skew lines from 3D figures. We also solve problems involving the distance from a point on a perpendicular bisector to both endpoints of a line segment, and do some examples here in a minute. But just remembering that when we talk about our parallel lines are lines that do not cross, they never intersect. Perpendicular lines are lines that will intersect at a 90-degree angle. The slope is going to, remember that, let's see here, slope is often referred to as m is slope, and it is y2 minus y1 over x2 minus x1. It's also referred to as the change in y over the change in x. Okay. A reciprocal. We need to remember that a reciprocal is a number that, when multiplied by another given number, results in the number 1. So an example of a reciprocal might be, well, I have the value of 7, or that is known as 7 over 1. A reciprocal would be 1 over 7, because when I multiply those two together, I get 7 over 7, or 1. So there you go. That's an example of a reciprocal. And then we could even do that reciprocal with a variable. If I have a variable m, that is also the same thing as m over 1. So the reciprocal of m over 1 would be 1 over m, which is going to result in m over m, or the value of 1 again. So again, just showing you some examples of reciprocals there. Rotation, we'll talk about rotation, but it's on a plane given a transformation which each point on a figure is turned through a given angle and direction around a given point. That point's going to be your center of gravity, and then of course the distance between that point and the center of gravity will remain the same. So it's a rigid transformation, and we have been working with that for the last several weeks. Skew. Now, skew is going to be a line that is neither parallel nor perpendicular. And that's what this example down here is meant to show, that we know that it says tell whether the lines appear parallel, perpendicular, or skew. So parallel lines have the same, they will never intersect, so they end up having the same slope. So, let's see here, AB and CD. Line AB and line CD appear to be parallel. So appear to be parallel, so using the parallel. EF, let's see here, EF and EF and FH appear to intersect at a 90 degrees, so they are going to be perpendicular. And then we are going to have AB and CG. Okay, those lines are neither parallel nor perpendicular, so that's where they fall into being skew. Okay, so just using some vocabulary there. So as we continue on talking about the slope of parallel and perpendicular lines, let's see, remember when we have a line, maybe we have y is going to be equal to 2x plus 1, and that is going to be, slope is going to be 2, because remember your slope-intercept form is y equals mx plus b. So anywhere along that line, my slope is going to remain constant in a linear equation or function. So I would start off at y is 1, and then I would go up 2 over 1, and that would be my rise over run, because my m is equal to 2, or 2 over 1, the change in y over the change in x. My rise over my run. So there is my y equals 2x plus 1. Now, a parallel line is going to have the exact same slope. So if I have, I don't want to use the same color, that could cause some problems. If I have y is equal to 3x plus 1, well, I may start here, but I'm going to have a different slope, right? Same y-intercept, but a different slope. So those are not going to be parallel. They're going to end up intersecting somewhere. But if I take and I graph y equals 2x minus 1, well, it's going to be right there, going to be my y-intercept of negative 1, and then I'm going to go up 2 over 1, up 2 over 1, and then that line is going to end up running that, and if you'll notice, again, my slope is going to be 2, so this function, and I'm sorry, that equation and that equation, they are going to be parallel because they have the same slope. But of course, just figuring out slope intersections. So as the rate of change, then the slopes of parallel or slopes of perpendicular lines. Slopes of perpendicular, right? Perpendicular. It's not a great symbol, but perpendicular lines will be, if you haven't experimented with this, they're going to be a negative reciprocal. My slopes will be. So if I look at these lines, we're going to say, okay, they could be parallel, they could be well, they're not parallel. They could be perpendicular, or maybe they're close to being perpendicular, but we need to check them. So what I can do is, in order to find out, let's see what the slopes are of these lines. So I'll start with my blue line, right? My blue line, and I have 2 points that they've given me. I have 3, 2, and I also have negative 1, negative 2. And I'm just going to go ahead and use my slope formula to figure out what the slope is of that line. And it is going to be, if I call this, if I call this would be my point 2, this would be my point 1. So my y2 minus y1, y2 minus y1 over x2 minus x1 is going to give me, the slope is going to be equal to 2 plus 2 over 3 plus 1, which is 4 over 4, or 1. So my slope is going to be equal to 1. Now if I look for the red line, looking at that line, I'm probably going to need to make some adjustments. So let's look at this point right here. That point is actually going to be negative 3 and a positive 2. So that is positive 2. And then this point down here is going to be 1, negative 2. So that's correct. And let's go back and double check that one. That one looks to be 3, 2, and this one looks to be correct. So this line has given us a negative 3, 2, and also a 1, negative 2. So this would be 0.2, 0.1, and my slope is going to be equal to y2 minus y1 over x2 minus x1. So I'm going to have a 4 over, and that's going to be positive 4 over negative 4, which is negative 1. So technically those two things, they are opposites, and I wouldn't be able to recognize those the way they're written if they are going to be the opposite reciprocal. This is 1 over 1, and this one down here could be negative 1 over 1, the opposite reciprocal. And let's see here. So thinking about some more here, using the slope criteria, we do want to identify, again, that on a coordinate plane, so when we are dealing with those parallel lines, so if I have this yellow line, I should be able to look at that and say, well, that's y equals, the slope is going to be up 2 over 1, so it's going to be 2x, y-intercept is going to be 2, plus 2, and a line that would be parallel to it would be this line right here. So if I have it, I look at my y-intercept, y equals some slope minus 3, right? 1, 2, 3, so that's negative 3. And then my slope is going to be 1 up 2 over 1, up 2 over 1. So that is also going to be 2. Both these guys are going to be parallel. Now if I were to add a third line in there, and let's say that we end up going from this point and my y-intercept here is going to be at positive 1. And then my slope, if I look, is going to be going down 1. And so that's a negative 1. Negative 1, and then it's going to be going positive 1, 2. So my slope is going to be a negative 1 over 2. And if we look at this slope of this line and the slopes of this line, this would be a negative reciprocal. And so that it will tell me that it's perpendicular. And if I were to multiply these together, so if I have my negative 1/2, and then I multiply it times my positive 2, that is going to give me negative 2 over 2 or negative 1. So I also can check it if my slopes, when I multiply them together, equal negative 1, then that forms a perpendicular. So basically, slope 1 times slope 2 gives me negative 1, then they are perpendicular. If they have the same slope, then they are parallel. And if we look at horizontal and vertical lines, I hope that you are familiar with the coordinate plane and that we know that x-axis is a horizontal line and the horizontal and the y-axis is a vertical line. And the slope of a vertical line is going to be some number over 0, which is a no-no because we can't have 0 in the denominator. And a horizontal line is going to be a rise of 0 over some number, and that is going to be a flat 0 slope. So m equals 0 here is undefined. So a vertical line has a undefined slope. So horizontal lines have a slope of 0, vertical lines have a slope that is undefined. And then, of course, a horizontal line is parallel with another horizontal line because if it's horizontal, that means its slope is 0. All vertical lines would also be parallel to each other because their slopes are all undefined. And then just remembering that my coordinate plane is built on a 90-degree or a perpendicular platform, so my y-axis and x-axis and corresponding values would also be perpendicular. As we look at this example, things that you should be able to figure out, one is calculating the slope of the line. So if I look at this red line, so I'm looking at line AB, you should be able to say, okay, well, I have a point here, I have a point here, and I have a point here, so I could use the slope formula to figure that out. I could also do my rise over run, and I could turn around and say, well, if I go from here to here, I'm going to go up 1 over 2, up 1 over 2. So the slope of AB is going to be a positive 1/2. We should possibly look at the blue line here, and the blue line is going to be line FG, okay, line FG. And if I look at that, I can look at it and say, hey, the slope looks positive, right? It's in a positive direction. So as I go through, I can go from this point, I can go up 1, 2, over 1, up 1, 2, over 1. So it looks like my slope here, my rise over run, is going to be up 2 over 1. And continuing around, let's look at the green line, which is going to be line HJ. And I can look at that, and you should recognize this as a negative slope immediately, okay? But if I go to count it, I'm going to go down 1, 2, which is negative, and then I'm going to go right 1, which is positive. Down 2, right 1. So I have a negative 2 over 1. That's the same thing though as 2 over negative 1. So either way, we are getting the negative 2 slope. And then we have a final purple line, and that is going to be line C and D. And we will go with, I'm going to go from here all the way down to here. So it looks like if I follow the line, it's negative, right? It's a negative slope. And I'm going to go down 1 over 2. Down 1, right 2. Down 1, right 2. So it is going to be a negative down 1, right 2, negative 1/2 slope. Okay, so there you go. We can easily calculate that by just counting our grid. However, if we weren't given a grid, we could have just used the slope formula. So if I look at, and if I just take AB, right, line AB, or instead of talking about line AB, let's talk about point A. Point A on the ordered pair is going to be -4, -2. -4, -2. And then point B is going to be a +4, and a 2. So I can use my slope formula, and I'll just call this y2, or point 2 and point 1. So it is going to be y2 minus y1 over x2 minus x1. So that is going to be -2 minus 2 over -4 minus 4, which is going to give me a -4 over -8, or a +1/2 when I simplify that. So my slope is going to be 1/2. So using the formula or counting the graph, whichever one works best for you, will give you the required information. So hopefully this was able to talk about some of the, complete the steps to prove the slope criteria for parallel and perpendicular lines using coordinate geometry, and determine if two lines are parallel or perpendicular. Prove the slope criteria for those perpendicular lines. And again, remembering that parallel lines have the same slope. Perpendicular lines have inverse negative reciprocals. And then if we multiply perpendicular slopes together, two lines we believe are perpendicular, if we multiply their slopes together, it becomes a -1. And then, of course, remembering the wonderful mathematical term for reciprocal, and being able to utilize that. So don't be afraid of the fraction, the F word. Often with slope it appears as a fraction, but that is merely just the rise over run. My slope is equal to my rise over run, or my change in y over my change in x, or we could talk about the rise over the run. Okay, so it's a fraction, but we just work with it.